Zeal Education Society, redefining excellence.
Hello students, in this video lecture of basic electrical engineering, the today's topic of discussion is charging and discharging of capacitor. The capacitor can be charged through the resistance by connecting the battery across it. The circuit for charging the and discharging of the capacitor is as given below. This is our capacitor plus minus. This is where the switch 1 is closed. 1 is for charging, 2 is for discharging. During charging, this is IC, charging current. Then voltage drop across the resistance is IC, R, and voltage across the capacitor is VC, small VC. This is IC. Now the position 1 for charging, two for discharge. Initially the charging rate of the capacitor is high and it can be charged to full voltage, that is the battery voltage, that is steady state condition. So the charging curve for the capacitor can be shown like this. This is time axis, this is voltage, and say this is the steady state condition. This is capital V. Now the charging curve, this is initially 0. So it increases exponentially and the expression for is given by small vc equal to capital V e raised to power, into bracket 1 minus e raised to power minus t upon tau. Now the tangent to this curve is known as initial rate of rise of voltage across the capacitor. Now when you draw the perpendicular to the voltage axis, this indicates the time constant tau equal to RC. And at this value can be obtained. So the initial rate of rise, of voltage across capacitor is dVc by dt equal to phi upon Cr equal to phi upon tau. Therefore, when time t equal to tau equal to RC, then voltage across capacitor Vc equal to phi into bracket 1 minus e raised to power minus 1 So this is nothing but 1 minus 1 upon E, and this is V into bracket 1 minus 1 upon 2.718, and this is equal to, so the Vc equal to 0.632 capital Phi. So thus the time constant can be defined as definition time constant. It is the time required. It is the time required to charge the voltage, to charge the capacitor, equal to 0.632 times the final steady state voltage. The final voltage, the steady state voltage, is equal to capital Phi. Steady state means when time reaches to infinity. That is Phi. So this is the time constant. It is the time required to charge the capacitor to 63.2% of the final steady state value. Now what is the charging current? Charging current so this can be shown like this. This is time axis. This is 0. This is I0 equal to V upon R, and it decreases exponentially. So this is IC equal to I0 e raised to power minus t upon tau. Now here also, if you draw the tangent line, this is 0.368 I0. So the initial charging, this is tau equal to RC. Initially, that is when t equal to 0, the charging current is maximum and given by I0 equal to V upon R. Now hence which is discharging of capacitor. When switch is moved to position 2, the capacitor discharged through the resistance R and the direction of current will reverse. Now the curves for the charging and discharging of the capacitors are this is minus I0, this is V, and this one is tau. This is the initial tangent line, the tangent line for the discharging current, where it cuts to the x-axis, and here these are the values. The expressions for the discharging voltage across the capacitor is equal to capital V e raised to power minus t upon tau, and this one is IC equal to minus I0 e raised to power minus t upon tau. So these are the expressions for the discharging current and discharging voltage respectively. So this charging and discharging of the capacitor is used for various sinusoidal electronic generator and for the lighting purpose also, for to take the charge and discharge of the light, means on and off, to make the on and off circuit. So student, we will stop here.